Good day everyone. Today we will tackle about the arithmetic gradient factors. Presented by Gesto Neerapalbis Abi Tubi. What is arithmetic gradient? An arithmetic gradient is a cash flow series that either increases or decreases by a constant amount g, the uniform gradient amount. Gradient is the amount of increase or decrease. Cash flow diagram. So this will be the cash flow diagram look like. In the case of increasing, as you noticed, we have in a first period, we have an amount, base amount A. In the second period, an amount G was added to the base amount, so it become A plus G. In the third year, another amount of G was added, so it become A plus 2G, and so on. In the case of a decreasing, from period 1, we have a base amount of A. In the year 2, an amount G was subtracted to the base amount, so it become A minus G. In the year 3, another G or gradient amount was subtracted, so it become A minus 2G. As you notice, it is increasing and decreasing. Compared to the uniform series annuity, it is equal in every period, but in this case, they are increasing with a constant amount that added the gradient. Derivation of uniform arithmetic gradient factors. So this will be the formulas used to solve the problem relating to this topic. So if you want to convert a uniform arithmetic gradient series to an equivalent uniform series or A prime G, we will use this formula: I over 1 over I minus n over parenthesis 1 plus I raised to n minus 1. If you want to convert the factor or the uniform arithmetic gradient series to its present worth or PG, we will use this formula: 1 over I bracket parenthesis 1 plus I raised to n minus 1 over I parenthesis 1 plus I raised to n minus n over parenthesis 1 plus I raised to n. If you want to convert the uniform arithmetic gradient series to its future worth or FG, you will use this formula: 1 over I bracket parenthesis 1 plus I raised to n minus 1 over I minus n. Sample problem. Suppose a man receives an initial annual salary of 60,000 pesos, increasing at a rate of 5,000 a year. If money is worth 10%, determine his equivalent uniform salary for a period of 8 years. So the given: in the first year, he have 60,000, salary of 60,000 pesos, and it was increased 5,000 a year as it was said, so it will be our gradient amount. Then the interest is 10% and the number of period is 8 years. So this will be our cash flow diagram look like. So as you notice, we have 60k in the first period. In the second period, 5,000 was added, so it becomes 65k. In the third period, another 5,000 was added, so it becomes 70k, and so on. So in the problem, you need to know the equivalent uniform salary. Na imbes na ingani increasing ang salary, what is the equivalent uniform salary annually? So This will be the red. So to solve that problem, so we need to divide first the cash flow diagram into two payments. So the base, which is the base, and the gradient, which is the red one. First, we need to convert this gradient into a uniform series. So our formula now is the equivalent uniform salary A prime is equal to base A sub 1, which is, we already know, 60k, plus the annual worth of gradient. So we need to first solve this and convert this into this. So we use the formula AG. So because we need to convert the arithmetic gradient series into an uniform series, so that we can find the annual worth of the gradient. So A sub 2 is equal to G bracket 1 over I minus N over parenthesis 1 plus I raised to N minus 1. Our G is the amount that was constantly added, which is 5,000, interest rate of 10%, and N is 8 years. By solving, we will come up with this result. So the annual worth of gradient AG is 15,022.39 pesos. Now, we will add this to the already know 60k base. So that we will come up with the result. We will solve for the equivalent uniform salary. So the equivalent uniform salary is 75,022.39 pesos. Problem 2. A highway department expects the cost of maintenance for a piece of heavy construction equipment to be 5,000 in year 1, to be 5,500 in year 2, to increase annually by 500 through year 10 at an interest rate of 10% per year. Determine the present worth of the 10 years of maintenance cost. So this will be the given. At first maintenance cost, year 1, we paid $5,000, and it increases $500 every year, so it will be our gradient amount. The interest is 10% and the number of period is 10 years, so we need to find the present worth of 10 years of maintenance cost. So this will be our cash flow diagram. So as I already said, you need to divide it into two payments, so the base A and the gradient G. So this will be in first period you have $5,000, in the second period $500 was added, so it become $5,500, and so on up to the period of 10 years. So we need to find the present worth of the period of 10 years. So our formula would be P is equal to present worth of base and PA plus present worth of gradient PG. So this will be our formula PA. We will use the formula in uniform series annuity, then added by if you want to convert the gradient uniform series, arithmetic series, into present worth, so this will be the formula. So P is equal to A for the base A, the PA bracket parenthesis 1 plus I in raised to n minus 1 over I parenthesis 1 plus I raised to n plus the gradient G times 1 over I bracket parenthesis 1 plus I raised to n minus 1 over I parenthesis 1 plus I raised to n minus n over 1 plus I raised to n. So our A is 5,000. So our base amount. Then our interest is 10. Then our number of period is 10. Our G is the amount added constantly is $500. So by solving, we will come up with the result that the present worth of the 10 years maintenance cost is $42,169. Problem 3. A small gold mine yielded an equipment of 500,000 pesos. During the first year, an operation for the second year, it become 460,000, and the amount is decreasing by 40,000 every year. Knowing that the mine can only operate up to 4 years, what is its equivalent annual yield if I is equal to 10%? So the given in a first period, we have a 500,000 pesos of yield. In the second year, it become 460,000. So it decreases about 40,000. So it will be our gradient amount. Our interest is 10%. Our N is 4 years. Number of period. So this will be our cash flow diagram. So at first, we have 500,000 base A. In the second year, it become 460K and so on. So to solve this problem, we need in the problem, we need to find the equivalent annual yield, which is the A. The imbes na decreasing, what is its equivalent value in uniform series? So to solve this problem, unlike sa increasing, sa decreasing is we need to add the deducted amount in the cash flow so that it will look like this. So as you notice, they are now equal. They are now in uniform series. So now we can find the future of this 500K future amount. Then we will deduct the future amount of the gradient. So we will use for the future of 500K, we will use the FA formula, and for future of the gradient, we will use the FG, or if we want to convert the uniform gradient series into a future worth, this will be the formula. So A bracket parenthesis 1 plus I raised to n minus 1 all over I minus G times 1 over I bracket parenthesis 1 plus I raised to n minus 1 over I minus n. So our A, which is our based amount, which is 500,000. And then our interest is 10 and our number of period is 4. Then our G, which is the amount that was constantly deducted each year, is 40,000, and so on. And then by solving, we will come up with an amount, with a future amount of 2,064,100 pesos. So now we have this future worth, we can now calculate the equivalent annual yield by using the FA formula from uniform series. So A bracket parenthesis 1 plus I raised to n minus 1 over I. So substitute, and then we will now come up with the equivalent annual yield A equal to 444,753.29 pesos. And now we will now apply the shifting process which was discussed in the last week. So the shifted arithmetic gradient. So in this case, we'll start at any time other than year 2. So ang gradient na mag-add siya constant amount will start at any time, either 2, 3, or year 5 na siya. And then but the present worth is still 2 years before gradient start. So this will be the cash flow diagram of the shifted arithmetic gradient. For example, for the period of 8, so the gradient started adding at 5th year in actual time. So at what was said, the present worth is still 2 years before the gradient start. So our present worth is from 1 to, so this will be our present worth in this period. Ito itong present worth. Example problem. If A or the base A amount is $100, G is the gradient amount $30, I the interest 8% per year, determine the present worth or P sub 0. So this will be our cash flow diagram. So for period of 8 years, we have a base amount of $100, then it was constantly added by year 6 by $30 each year. So first we need to find the present worth of the gradient. So as it was said earlier, the present worth is 2 years from the start of the addition of the amount of the gradient. So 1, 2. So this will be, this period are the present worth of the gradient. So this will be the formula PG. You want to convert the arithmetic gradient series into present worth. So this will be the formula. P sub G is equal to G times 1 over I bracket parenthesis 1 plus I raised to n minus 1 over I parenthesis 1 plus I raised to n minus n over 1 plus I raised to n. So our G, it was said the gradient is $30. Our interest is 8%. Our period is 4. So 1, 2, 3, 4. So by solving, we will come up with the P sub G is equal to $139.50. So this will be our present worth of the gradient. And now, you should find the present worth of the gradient at t is equal to 0. T is equal to 0. So, this present worth gradient at t is equal to 4 would become our future worth for the gradient. So we will use the PF formula. So P is equal to F parenthesis 1 over parenthesis 1 plus I raised to N. So our F future worth is 139.50. Then substitute. Then we will come up with our present worth of gradient at t is equal to 0 is equal to $102.54. And now we will find the present worth of the base at t is 0. So the formula we follow is the PA multiplied by PF. So P sub B, or present worth by base, is equal to A bracket parenthesis 1 plus I raised to N minus 1 over I parenthesis 1 plus I raised to N multiplied by PF, which is parenthesis 1 over parenthesis 1 divided by I plus I minus plus I raised to N. So this will be the result. So our A, it was said that our base amount is 100, then and so on. Then by solving, we will come up with the result of $243.45. And now we can find the total present worth of the problem by adding the two, by adding the present worth of the base and the present worth of the gradient at t is equal to 0. So the present worth, the total present worth is equal to $345.99. And now we will proceed to the next part, which is we will find the equivalent annual amount or the uniform series. If A is $100, G is $30, I is 8% per year. Determine the A sub t for t is equal to 1 to 8. So this will be our cash flow diagram. So as you notice, mo na itong gisolve ganina. And then we need to find this arrow, the value of this arrow, which is the equivalent uniform series of this gradient, which is kaning orange. So first we need to find the A sub G for the gradient. So first kaning gradient we need to find. So we already know the present worth of the gradient, so which is $102.54. So we will use the AP formula, which A sub G is equal to P bracket I parenthesis 1 plus I raised to N over parenthesis 1 plus I raised to N minus 1, and our P is 102.54, our interest is 8%, our N is 8. So by solving, it come up with an amount of A sub G is equal to $17.84. So now we will solve the equivalent annual uniform series sa base. So now we will still use the AP na formula. So our formula would be A sub B is equal to P bracket I parenthesis 1 plus I raised to N over parenthesis 1 plus I raised to N minus 1. Our P is $243.45. Then 8% interest and 8 number of periods. By solving, we will come up with A sub B is equal to $42.36. And now, to find the total annual uniform series of this problem, we now add the A sub G plus A sub B. So, the result is $60.20. So, this will be, each of these is amounting $60.20. And that's all. Thank you for watching. Thank you for listening. For nominal and effective interest. Nominal rate of interest, or I sub NR, is the basic annual rate of interest. It does not take compounding into account. It is also known as the stated interest rate. It is stated as a simple interest. While ang effective rate of interest, I sub EFF, is a rate that takes compounding into account. It is the actual annual rate considering the compounding. So this will be the formula of the effective rate is equal to 1 plus parenthesis 1 plus I sub NR over M raised to M, where M is the number of interest period per year. Sample problem. What is the effective rate corresponding to 18% compounded daily? Assume 1 year is equal to 360 days. By using the formula, I sub F is equal to parenthesis 1 plus I sub NR over M raised to M minus 1. So our 18 is the nominal interest rate. And then we want to find the effective rate. So 360 ang M. So the effective interest rate is equal to 19.72%. So this will be the effective interest rate. As you notice, the nominal interest rate and effective interest rate, the effective interest rate is larger compared to the nominal interest rate. In other words, the effective interest rate is the exact amount earned by principal per year. And